Hey guys, Alan from Hack Gadgets here. So this isn't going to be the typical project. What this is a drawer out of a fridge, and you can see it's cracked here. It's cracked there. It's cracked in the back here, and it's also cracked on this side. I've been to a number of the local appliance repair shops in town here. All of them have a lot of these used things, from older fridges. This fridge, I guess, is fairly new, so they don't actually have replacements for them that have come out of used fridges that got scrapped. So my only option is to pay new, and I called Sears. This one only comes in a pair of two. The other one is fine, but I would have to get both of them. And I believe it was $75 or something like that shipped. Well, I think that's pretty ridiculous. This is a out of a really good fridge in a rental property, and I believe the fridge we bought used, it was probably 4 years old when we bought it, and I think we paid, $500 or $600 for the fridge. So to pay 10% of its value for a crack in this plastic here, I think is kind of ridiculous. So what I would like to do is try to repair it. So initially I thought, just using some packing tape or something, run a strip on here, that would probably work. However, it would still have a lot of its strength reduced. And the other thing I was thinking of is actually trying to apply some acrylic plastic on here. And I took a look on the actual unit here. So this unit only has writing. You can see it says there, if I can get the right light, hand wash in warm water. And there's no French. And on the back it has a part number embossed into it. Again, I'll see if I can get the light good here. Okay, so there's the part number. And the part I'm really interested in is just after the part number. It says PC and PS. Now the reason I was just interested if there was any French on the other side, we're in Canada here, most things have French in it now, is, generally the PS would be some abbreviation in English, and the PC would be English, and the PS underneath it would be the French equivalent abbreviation. But since there's no French on here, I'm assuming both of those abbreviations are English. So what I did is I took a look up on a website here, and just to see what the abbreviation for the PC and PS were. Let me just pull that up here. Okay, so here's a good old Wikipedia page. I'm assuming it's correct right now, though, for this information. And let's see here. So, okay, so there's polystyrene, PS, packing foam, peanuts, food containers, plastic Tupperware, disposable cups, plates, cutlery, CD and cassette boxes. Now, I guess obviously in different methods it can be used for different things, but the CD and cassette box has the same consistency as this box. And let's see here. The other one is this one right here that's highlighted, the polycarbonate. So that's used for compact discs themselves, eyeglasses, riot shields, security windows, traffic lights, and lenses. So this plastic in this unit is actually a combination of both of those plastics. And acrylic is what I've been working with for the last few years. Cutting it with the laser cutter, etc. And so this is a sheet of uncut acrylic, and you can see I'll just pull the protective plastic off here on both sides. So this is what the acrylic looks like. It's quite thin. This is 3mm acrylic, well, which is quite a bit thicker than this unit, obviously. But so what I'm thinking of doing is cutting this on the laser machine, just to create some patches there. And typically what I've been using in the past for welding acrylic together is this stuff here. It is called Weld On 4, and it's kind of smudged here, but this basically says acrylic. And it doesn't say on the tin, as far as I could see, if it was good for polycarbonate and polystyrene, but luckily on their website, they actually do have some information. So here is the Weld On information here. And so it basically says, let me find it, yeah, so here it is. Here it works with polystyrenes, and it works with polycarbonate. Now, the only thing I'm concerned about is where it says polycarbonates to themselves. It's talking about bonding. I'm hoping that that's not saying that it can only do polycarbonate to itself, because I'm wanting to bond polycarbonate and polystyrene to acrylic. So we'll see if that works or not. I'm hoping and assuming it will, but well, time will tell. Let's let's measure and cut some pieces and bond them on there and give it a try. Let's see what happens. And I just remembered I also have this Weld On 16, which is also a solvent cement for acrylic, and where this one here is water thin, this one here comes in more of a paste, so it's very jelly. You squeeze it out of this tube like toothpaste, and you squish it between your items. So I'm thinking this number 16 might be a better application for putting these large squares of acrylic on here. But what I'm going to attempt to do first is, since we have these large gaps here, I'm going to hold them together, and using some of the Weld On 4, what you do is you put it into one of these little very fine tipped droppers. You can see, you might not be able to see the hole there, but it's a very, very fine hole. And so this dropper basically just allows the material to very, very slowly seep into the crack. And what this is doing is it's actually not gluing the materials together. What it's doing is it's actually melting the plastic, or the acrylic in this case, and then allowing the acrylic to bond with the adjacent acrylic. So it's actually making it, in theory, just as strong as if there was no joint there. And obviously that's kind of what we're looking for here. We want it as strong as possible. Okay, so I've placed a little bit of it in this container here, and I'm just applying it. I've already done most of the top here, so all you do is you just apply a drop of it. Let's see if I can get this in camera nicely. So you just apply a small drop, and it gets sucked in to the joint with capillary action. And I have the joint just held together. There's some tape on the back of this one here, and I just got some tape across the top of there, just putting a bit of tension on it. So I'm just going to go right along that joint there and just carefully drop in some drops of this and see what happens. Okay, so I've completed this front joint. Unfortunately, my technique isn't great, so I did have a couple little runaway trails of the acrylic cement there, but it did find its way into all of those joints. And when I got the technique right, so what I was initially doing is I was sort of holding it upright like this and sort of painting it in there. Obviously the best technique is to hold it flat. So hold it like so, and then basically just run it along very gently and slowly, and letting it form into there. Okay, so what I've done is I've applied 2 more pieces of tape here and here. I haven't connected those to the front because I don't want to put any inward pressure on here. I've just attached them to the sides here, and that basically has closed these joints up. And I'm going to do the same thing to these 2 cracks on the side. I'm going to apply it, and we'll see what happens. Okay, so this is the next day, and everything is obviously dry. This is about 24 hours later, and these joints are all nice and strong now. And obviously the most important joint was this one right in the front here. So it did discolor the plastic here a little bit where it ran, but this is a very fragile point, and you can see here. Let's get this on camera nicely. So if I push on this portion right here, you can see it's actually moving the whole thing. So that thing is, I'm putting quite a bit of pressure. I'm probably putting like 3 or 4 pounds pressure on there to make it deflect like that, and it's holding up good. And what's going to happen is there's going to be a piece of acrylic cut and placed in behind here, as well as a large piece of acrylic cut and placed in behind here. So I'm thinking that should be extremely strong once we're done. So let me cut some acrylic, and we'll place it on, and hopefully 24 hours from now this thing should be stronger than new. Okay, so some pieces of acrylic have been cut. Now, again, it's 3 millimeters thick. I don't know if I can get a good angle on that. There we go. These are cut on a machine, but you can cut them on a table saw or with anything else. So this is the large one here. This one is going to basically go in place here, and there is going to be an issue. I'll tell you about that in a second. And then I believe this one here is going to be covering up this crack here. This large crack is going to be done with this one up in here. And then this piece here will go underneath this lip here. So it'll just basically go in here and cover up that one. Now the issue is this one here, this is actually, there's a slight curve in here. And for this large one, which is going to go on the inside, like so, you can see here. So this is a straight edge, and you can see there is quite a curve there. So what I'm planning on doing is I'm just going to heat this up a little bit, just with a heat gun, just so it can bend in this direction a bit, so it can contour in there. And I'll do the same thing with this one here. And then I'll be gluing it in with the Weld On number 16. And this is more of a paste. And yeah, we'll see how that goes. Okay, so I've done this joint here. I'm going to do this one here. This is going to use this piece of acrylic. Let's make some room here, and I'm going to use the adhesive here, or the cement I should say. And let me zoom in so we can get a good shot of this. Okay, so this cement is quite thick, and I'm just going to put some in the center here. And I'm not going to paint it all the way across. I've already done one of them, and it worked quite well. The other one I just squirted some directly in the center. And hopefully you can get the shot of it squeezing. So as I squeeze this, you can see that material just runs right to the edges. Now there might be a slight contour in this, so it might not be possible to get it covering 100% of this joint, but yeah, so right there, it certainly is covering about, you know, probably 95% of it. You can see it right on the corner here, and then this corner, and a little bit on this edge. It's not covering, but the center here is 100%, and obviously the crack is going right through here. So that will, I think, be a very extremely strong fix. I'm just going to move this up a little bit here. There we go. Okay, I'm just going to throw some tape on here. Because right now it's very easy to be moved. This tape will allow it to set up and not be moved around. Okay, a little bit of heat on the other ones, and I think this repair will be done. Okay, so the first curved piece has been done, and this is the one that goes right in here. And what I've done is I've just heated this up a little bit, and then using a pair of gloves I just held it in place so it would sort of conform to that. And so you can see it's not curved much, but just enough so you can see there's a slight curve there. And hard to see this way, but there's also a slight curve in that direction. So that'll perfectly form the contours of that. So I'll put this in place. I'll do the same thing with this one. I'll form that one so it goes in there, and then we'll glue them in place. Okay, so this last piece was just heated up. It's still quite warm, and I'm just pressing it hard against the surface here to put a curve in it. And let's take a look at it here. So yeah, you can probably see, if I hold it up just right, you can see the bend there. So that's the curve of the actual bottom of this, and the top slightly curves also. So now this does hold that curve perfectly. I'll let it cool down for a few minutes, and then we'll attach it. Okay, it's been about 30 seconds. It's been cooled quite a bit now. It's still slightly warm to the touch, but it's not hot. Let's get some of this on here. So I'm not sure what the optimal method of depositing this is, but I'm just going to use an S pattern. We'll see how that works. Works pretty well. You know, I might need a bit more on here. I will need just a bit more. Okay, we got some trapped air bubbles in there. I don't think there's much we can do about that, unfortunately. So it's not going to look as clear as some of the other joints. Oh well. I'll just tape this in place so it can dry. Nice thing about the 16 is it seems to hold things in place. It has a good tack. The other one is very thin, thinner than water in fact, and it obviously doesn't hold anything in place. But this one you can take your hands off it for a little bit and it will will stay. Okay, so that is in there good. Okay, so in 24 hours we'll take the tape off, and I'm thinking these sections will be stronger than it was originally. So we'll take a look at it tomorrow. Okay, so this is the next day, I believe day number 3. And as you can see, this is all dry and it's now very strong. So I'm not sure if I'm going to call this a success or not, because the repair is very far from non-obvious, and it's very far from good looking. Mainly because of all these bubbles here. So I'm not sure if there's something I could have done differently to prevent this amount of bubbling in these connections here. But well, it is extremely strong, which is a good thing. So it's functional. It will be usable. But I'm not going to say that this is an ideal repair. I think if I were going to do this again, what I would have done is use a technique where I would have tipped it up flat and only used, which one was it? Only used the Weld On number 4, and again just use that with the dropper bottle here, and just carefully fed that into the cracks, and only done the cracks. You know, hold it together for the first day with the tape, just like I did. And I think I would have left it at that, because if done properly, that would have been an almost invisible fix. You know, it would have still had the very thin crack, but that crack would then be held together. I'm thinking quite strongly. This is obviously much stronger, but isn't the best looking. So it's a learning process. Hopefully somebody can take something away from this, and maybe extend the life out of you know, one of these cracked drawers. It's crazy how much they charge for them, and the price is still on here. I bought this from Tap Plastic, and yeah, this was $8.90. Now, I'm in Canada. We don't have a Tap Plastic here, and I couldn't find this locally, so you know, I think it cost me probably the same amount or more in shipping to get this to me. But you know, this, for what I do, this will be like probably a 5-year supply. So, you know, well worth it to have on hand. And if you're bonding acrylic to acrylic, or as we see here, a couple other plastics, it works very well.